the length on paper to the real length of something. So you've used a map before, whether it was a topographic map or a map on Google Maps or a hard copy of a map. And could you give me an example of a scale?
We'll say like 10 inches every 500 miles.
Okay, so one example is 1 inch is equal to 500 miles. So the 500 miles is the real length. And the 1 inches is the length on the map. Right, everybody understands that? So hold up an inch, right, you have an inch, you know that if the scale says an inch is equal to 500 miles, if you put the inch down on a piece of paper, you're looking at 500 miles. Okay? So does everybody get that on the left side is the inches on paper, is paper length, and on the right side is the miles. Okay, so we're going to look at a few different kinds of scales. One is called a civil engineering scale, or it's also called just an engineering scale. And what you have with you is an engineering scale. And examples are 1 inch is equal to 100 feet. 1 inch is equal to 20 feet. 1 inch is equal to 3 feet. 1 inch is equal to 600 feet. 1 inch is equal to 40 feet. 1 inch is equal to 5,000 feet. What do you notice similarity between those 6 examples?
All 1 inch.
They all have 1 inch on the left side, and they have an equal sign, and on the right side is what?
Some value.
Something in feet. Notice the ones, I did not write an example of 1 inch is equal to 7 feet. I did not write 1 inch is equal to 80 feet. I did not write 1 inch is equal to 90 feet. Because this side either has to be a 1, a 2, a 3, a 4, a 5, or a 6. So take a look at your engineering scale. You'll notice, for mine right here, it says 10 on one side, it says 30, it says 50, and on the other side it says 60, 20, 40. Who does not have an engineering scale with them right now? Do you want to buy one right now, or you want to just borrow one right now?
How much is it?
Okay, so part of the homework is to make sure you had your equipment, right? I've given you 3 weeks, and I also said to everybody, if you had an issue buying it because of money, come and see me and I can take care of it. I don't want people to show up for class not ready. Who needs to borrow a scale? Come up and get it. Okay, so does everybody get then an engineering scale? We're only doing 10, 20, 30, 40, 50, and 60. No 70, no 80. Okay, so let's say a scale of 1 inch is equal to 60 feet doesn't work. What would the next scale be that you could do? So let's think about it another way. 60 feet in real life is equal to 1 inch on paper. 60 feet in real life is equal to 1 inch on paper. But you know you can't do a 70 scale, you can't do an 80 scale, and you can't do a 90 scale. So what would you have to do? 1 inch is equal to 100 feet. That would be the next one that you go to. Everybody good? Okay. Now, these are examples of scales. There's another word that you need to know is called sizes. And sizes is converting the scale to something where you're using the same units. So for the engineering, you notice it's 1 inch to so many feet. Let's take this 1 inch is equal to 100 feet. If I wanted to have both of these with the same units on the left and the right side, what would the scale be? 1 inch is equal to?
100 times 12?
So if right now I have inches on the left and I have feet on the right, if I wanted to have it where they both had the same amount, same units on both sides, if the left stayed to 1 inches, what would be on the right? 1200. So this is equivalent to a size of 1 to 1200. Notice that the equal sign has been replaced with colon. So what do you think the colon means? Notice when I put the colon, I don't have to put units, right? So what does it mean? Units are the same. So what is 1 inch is equal to 20 feet? What does that come out to be? 1 to? What? 240. What would 1 inch is equal to 3 feet be? 1 to 36. How about the next one?
7,200.
7,200. Good. This next one?
480.
Right, so what are you doing to all these numbers? Multiplying by 12. 5,000?
60,000.
60,000. So does everybody get the understand the difference between the scale and the size? Okay, talk to the person next to you, make sure you both understand. Did anybody pull it up on their phone, the Canvas page? Okay, everybody good? Yep. So, is this type of scale called an engineering scale? Yes. Is this type of scale called a civil engineering scale? Yes. Is this type of scale called an engineering scale? Yes. Is it called a civil engineering scale? Yes. Is it called a mechanical engineering scale? No. Is it called an electrical engineering scale? Is it called an engineering scale? Yes. Okay. So now the next scale we're going to look at is mechanical. Mechanical engineering scale. On the civil engineering scale, on the left was 1 inch and on the right was so many feet, and we knew that it had to be a 1 to 6. The mechanical engineering scale, on the left is a fraction of an inch. A fraction of an inch. And on the right is 1 inch. So give me an example of a scale that has a fraction of an inch on the left and an inch on the right. 1/8. 1/8 of an inch is equal to 1 inch. Give me another one. 1/16. Boy, you want to go smaller and smaller. Let's go bigger now. 1/4. 1/4. Oh, I'm putting feet. Shoot. They're all supposed to be inches. So now, tell me what this, talk to the person next to you. What is the size of each of these scales? Let me point out something. Notice that when you do a scale, you always have 1 on the left side. Okay, so what is a 1/8 inch is equal to 1 inch scale written in a size? 1:8. And it's just, the colon is 2, 1 to 2, 1 to 8. What's this one? 1/16. What's this? 1/4. How about 2 inches is equal to 1 inch? Now, does that first seem like a mechanical engineering scale? Okay, you might say no, because the left side is supposed to be a fraction of an inch, but 2 is really 2/1, so it is a fraction of the inch. The important thing is the right side has to be an inch. So 2 to 1, how would I write that one? Good, but it's whole numbers. 2 to 1. So there's an exception. Usually it starts with 1, but when you do mechanical engineering, it could be 2 to 1. Okay, so now, I want you to tell me, what is the difference, wait, I'm gonna do 1/2 to 1, and what is that, what is a 1/2 to 1 gonna come out to be? 1 to 2. I wanna know what the difference is between these two. So, if I am drawing this, and it's, give me one of your engineering scales, because they're a little longer than mine. Okay, so I don't know how, it might be hard for you to see. But it's, let's say it's 5 inches long. So this divider is 5 inches long. If you draw, so I'm gonna put it on another piece of paper. My divider is 5 inches long. If I use a 1 to 2 size or scale, how big is it going to be on paper? And if I do the 2 to 1, what's the length on paper? Talk to the person next to you.
The idea is that what kind of data?
Oh, one to two, we have to sign.
Yeah, there's a Mexican place, they have chicken.
Okay, let me interject. The scale is the adjective for the paper. When it says 2 to 1, that's the adjective describing the paper, not describing the real thing. Because the real thing is what it is. The only thing you have control over is how you want to draw it. So if you're drawing something 2 to 1, it's the drawing that's 2 to 1. The drawing is 1 to 2. The real thing is the length it is. Okay, so ask again, talk. What's the difference between 2 to 1 and 1 to 2?
Actual size is less than the scale. The actual size. We're on the same page.
Okay, so if I am using a scale, if the divider is the real length of the divider, is 5 inches long, and I'm using a scale of 1 to 2, how long is the divider on paper? 2.5 inches. If I'm doing it 2 to 1, how big is the divider? How long is the divider going to be on paper? 10 inches. So let's talk about why. This 2 to 1 that we came up to, it said 2 inches on paper is equal to 1 inch in the real world. So if it's 5 inches in real, if you're saying it's 1 to 2, it means 2 inches real is equal to 1 inch on paper. Another way you could say this is you could say this, bring that 2 back down, it's half size. Again, it's an adjective. The drawing is half the size of the real divider. If this is called half size, what do you think this is called? Double size. Which is the same as 1 inch is real. For every 1 inch real, it equals 2 inches on paper. What's that? 4 to 1? I think it's called quadruple size. Quadruple size. What does this mean? The drawing is going to be what? Right, the drawing is 4 times the size of the reel. If I wanted to draw that CNC mill on a piece of A-size paper, what would be a scale that would make it fit? How about if I wanted to draw it double size? Does it fit on the paper? How about half size? No. Quarter size? No. So what we're doing is shrinking this down in our minds, right? Think of it half the size, it's still not gonna fit on paper. Quarter the size, it's still not gonna fit on paper. Maybe we're gonna have to go back to Andrews and 1/16, maybe it'll fit on the paper. Okay? So when do you double size something? When it's really small. So what type of engineer designs things that are really tiny? Mechanical maybe, but who usually always? Electrical. They're done, chips, right? Chips and certain transistors and resistors. They're tiny. I'm not gonna wanna put this little thing drawn on a paper like this. I'm gonna have to blow it up. Everybody got it? Okay, everybody put their hands up like this. This is how big, go like this, where I am, like this. Okay, this is how big, make your hands as big as mine. Okay, this is how big your object is. If you double size it, how big is your paper? Go back. If you're quarter sizing it on paper, how big is the paper gonna be? You getting it? Okay. So what's the difference between mechanical engineering and civil engineering scale? Mechanical, yeah, it tends to be smaller stuff, but you know, that could be designed by a mechanical engineer, right? Right, so maybe that would be 1/16. The main difference is that mechanical engineers work in inches only. Okay, if they're designing something, they're reporting it in inches. Or civil engineers, they're designing things in feet. Robert, what's your experience at Foxton like when you see plans? Are you ever working with large things?
Not that large, probably maybe like 11 inches,
11 inches.
20 inches here and there.
Okay,
With
when-
spacers that are like 1 inch, you know,
Okay,
unless
so if an object is 20 inches long, does the mechanical engineer report it as 20 inches, or do they say 1 foot so many inches?
No, it's in inches.
Inches.
Yeah.
So the main difference is that mechanical engineers work in inches and civil engineers work in feet. Okay? Andrew?
That's just in the United States, right?
Yeah, yeah. Oh, yeah. If we were somewhere else, what would we be dealing with? Metric. And then we don't have to go back and forth to all these different distances and, you know. When I first taught this class a long time ago, I had everybody get an engineering scale, I had everybody get an architecture scale, I had everybody getting a mechanical engineering scale, and I just thought, we're just gonna work on engineering scale. Those of you who are civils, okay, and by the way, those of you who are civils, if you have not taken surveying yet, which is required for, if you're interested in civil engineering, structural engineering, architectural engineering, environmental engineering, or agricultural engineering, you need to take surveying, and surveying is offered the fall of odd years. You want to take it this coming fall, otherwise you have to wait 2 years. Okay, and it's part of the licensing exam for civil engineers, so make sure you take it. My train of thought. Oh, so those of you who are civils, you really need to learn how to use an architectural scale, and I could teach you. I was a civil too. I can teach you how to use the architectural scale, but I think right now, I want to make sure everyone's comfortable using this one scale. Okay, so, remember the packet I gave you? The next page of the packet is this. So working with the person next to you, which one of these are engineering scales? Which one of these are engineering scales? So write down, and we could just use the word CE for civil engineering and ME for mechanical engineering. So which ones are ME scales and which